Okay, well, I just direct your attention to this map here, which shows basically the Northern Appalachian system, where Newfoundland sits with respect to the Northern Appalachians. This green and red belt here is the extent of the Appalachians, and you can see that there's large basinal areas in the northeastern United States that are well known as producers now that extend into West Newfoundland. So this is yet another reason why we're so excited about the potential for West Newfoundland, by way of analogy with the near geology and continuous geology in the United States. These are basically equivalent rocks to the kind of resources we're looking for in West Newfoundland. So you can see the cause of our excitement here. If we just focus in on this colored map here of a portion of West Newfoundland, we call the Langdon. It includes the Greenpoint Shale throughout. And without worrying too much about all the colors, basically our play extends from the basically shore of the Port-au-Port Bay here on Port-au-Port Peninsula all the way down north to the area of Parsons Pond. The extent of that in the onshore and offshore is about 200 kilometers, so you can see this is a very large area for a small company such as ours to have access to, basically along the shoreline and in and around the shoreline areas of West Newfoundland. To focus in on our current operations, we're sitting here at the tip of Shoal Point in Port-au-Port Bay, West Newfoundland. Our company's drilled 2 wells from this, 2K39 and 3K39 were basically spotted at the tip of Shoal Point and drilled offshore in a direction just off to the northeast, like something like this. If we were to look at that in profile, basically a cross-section showing how these wells were drilled using the ability to steer the bit and drill a well, in this case at a 45-degree angle. You can see the green and the red here refer to our earlier wells. So it's this kind of technology that gives us great access to the resource and how we want to extract it in the future. Okay, I'd like to point out here the position of a profile seismic line and an interpretation of that seismic line. This profile sits basically out at the head of the bay across from Long Point here. So this profile tells us essentially what the shape of the wedge that includes the Greenpoint Formation is. This yellow material on here in cross-section basically is the same as the yellow material you see on the map here. That's the unit that contains the Greenpoint. What we're really happy about here is the thickness of this unit. You can see it in this well that was drilled off Long Point. It represents about 3,000 meters of section. You can see the panels here that represent the thickening, the over-thickening, the structural thickening of the Greenpoint Shale. So this, again, is one thing that's making us very excited. I haven't anywhere else in my travels in geology seen anything that quite gives us this kind of potential thickness of a resource. And that's one of the reasons that we're really focusing on this area at the moment. This is the well from close to the surface down to our TD of 1740 meters. And what you see here, without worrying too much about what these curves mean, is a series of different indications. This log over here basically measures liquid hydrocarbons in the drilling mud system. This interpretation in here from NewTek, our log analysts in Houston, show saturation of oil pretty much up and down through the borehole. Similarly, this is more of a conventional log suite over here that can be interpreted in terms of telling us where the hydrocarbons are. This column on the right here are basically small 5-meter samples that show fluorescence from the well site geologist, showing us that we have live oil in the tight shale rock within the section itself. So all these together correspond to tell us that we have a very thick oil-bearing section in this well. Okay, I just want to point to this table for a moment here. This has been compiled recently by our specialists in log analysis out of Houston, a company called NewTek. And what they've done is compare the very famous shale basins in the States, and you've heard some of these names, the Barnett, the Marcellus, the Eagle Ford, the Utica, and so on. On top here with the key parameters that go into the making of a great shale play. And down here we have 3 or 4 of the zones that we've identified in our well that are important in 3K39. I just want to point out our recent extended leak-off test gave us some engineering data that makes us very excited about this. And particularly in terms of the average permeability and the pressure of the formation itself. The permeability here is about 21 times greater than the average for the basins in the United States itself. So that's obviously telling us that we've got information that could lead to a very productive tests here, and also ultimate recoveries could be very high. Pressure also goes into that factor as well. So this is obviously a lot of really good information that we've gathered from our recent testing.